8403. How should a quick stop be initiated? A. Raise collective pitch. B. Apply aft cyclic. C. Decrease RPM while raising collective pitch. The correct answer is B. To initiate a quick stop maneuver in a helicopter, the pilot should apply aft cyclic. A quick stop maneuver is a technique used to rapidly decelerate the helicopter while maintaining a hover or near hover position. It is often performed in emergency situations or during training exercises. To initiate the quick stop, the pilot needs to apply aft cyclic input. The cyclic control in a helicopter is used to control the aircraft's attitude and make adjustments to its pitch, roll, and yaw. By applying aft cyclic, the pilot tilts the helicopter's rotor disc slightly backward, which increases the angle of attack of the rotor blades and generates more lift in the rear part of the rotor disc. This results in a decelerating force that opposes the forward momentum of the helicopter, causing it to slow down. While collective pitch control and throttle adjustments may also be utilized during the maneuver to maintain control and manage power, the primary action to initiate the quick stop is applying aft cyclic. Therefore, to execute a quick stop maneuver in a helicopter, the pilot should apply aft cyclic. 8404. How does V&E speed vary with altitude? A. Remains the same at all altitudes. B. Increases with an increase in altitude. C. Decreases with altitude and increase in altitude. The correct answer is C. V&E speed, or rotation speed, refers to the speed at which an aircraft lifts off or rotates during takeoff. It represents the minimum speed required for the aircraft to safely become airborne. V&E speed decreases with an increase in altitude. This is primarily due to the decrease in air density as altitude increases. As the aircraft climbs to higher altitudes, the air becomes less dense, resulting in reduced lift generation for the same indicated airspeed. To compensate for the lower air density at higher altitudes, the aircraft needs a lower ground speed to generate sufficient lift for rotation and takeoff. Therefore, the V&E speed decreases as altitude increases to account for the decreased air density and maintain a safe takeoff speed. It's important for pilots to consider the effect of altitude on V&E speed and consult the aircraft's performance charts or operating manuals to determine the appropriate rotation speed for different altitudes. In summary, V&E speed decreases with an increase in altitude due to the decrease in air density. This requires a lower ground speed to generate sufficient lift for rotation and takeoff. 8405. What limits the high airspeed potential of a helicopter? A. Harmonic resonance. B. Retreating blade stall. C. Rotor RPM limitations. The correct answer is B. The high airspeed potential of a helicopter is primarily limited by the phenomenon known as retreating blade stall. Retreating blade stall occurs when the helicopter's advancing blade generates more lift than the retreating blade due to the difference in relative airflow. As a helicopter increases its forward airspeed, the advancing blade experiences an increased airflow velocity and generates more lift. However, the retreating blade experiences a decrease in relative airflow velocity, leading to a decrease in lift generation. At a certain airspeed, known as the critical retreating blade stall speed, the retreating blade may reach its critical angle of attack and stall. When this happens, the lift on the retreating side decreases significantly, potentially causing an imbalance in lift and destabilizing the helicopter. Retreating blade stall is a critical limitation for high-speed flight in helicopters. To mitigate this issue, helicopters incorporate design features such as blade twist, rotor tilt, and cyclic control inputs to manage the differences in lift between the advancing and retreating blades. However, there is still a practical limit to the airspeed that helicopters can safely achieve without encountering retreating blade stall. While harmonic and rotor RPM limitations are also important factors to consider for safe helicopter operations, retreating blade stall is the primary factor that limits the high airspeed potential of a helicopter. 8406. What corrective action can a pilot take to recover from vortex ring state? A. Increase forward speed and raise collective pitch. B. Decrease forward speed and partially raise collective pitch. C. Increase forward speed and partially lower collective pitch. The correct answer is C. Vortex ring state, also known as settling with power or a helicopter's power settling, is a dangerous aerodynamic condition that can occur during a vertical descent or low-speed hover. It is characterized by a loss of effective translational lift and a rapid descent rate despite increased power being applied. To recover from vortex ring state, the pilot should take the following corrective action. Increase forward speed. By transitioning the helicopter into forward flight, the relative wind increases, providing additional airflow through the rotor system. Increasing forward speed helps to break the cycle of descending airflow that contributes to vortex ring state. Partially lower collective pitch. Lowering the collective pitch reduces the overall lift produced by the rotor system, helping to decrease the power required and alleviate the conditions that contribute to vortex ring state. This action prevents further descent and helps the helicopter to regain effective translational lift. It is important to note that recovery from vortex ring state should not involve abrupt or excessive collective pitch inputs, as this could worsen the condition or lead to other dangerous situations. Smooth and gradual collective pitch adjustments, along with an increase in forward speed, are key to recovering from vortex ring state safely. 8406-1. A traditional recovery from a vortex ring state condition is accomplished by A. Increasing collective pitch. B. Increasing airspeed and partially lowering collective pitch. C. Lateral cyclic thrust combined with an increase in power and lateral anti-torque thrust. The correct answer is B. In a traditional recovery from a vortex ring state condition, the pilot typically follows a procedure that involves increasing airspeed and partially lowering collective pitch. This helps to break the cycle of descending airflow and regain effective translational lift. Vortex ring state, also known as settling with power or power settling, is a dangerous aerodynamic condition that can occur during a vertical descent or low-speed hover. It is characterized by a loss of effective translational lift and a rapid descent rate despite increased power being applied. To recover from vortex ring state, the pilot should take the following corrective action. Increase airspeed. Transitioning the helicopter into forward flight increases the relative wind, which provides additional airflow through the rotor system. Increasing airspeed helps to break the cycle of descending airflow that contributes to vortex ring state. Partially lower collective pitch. Lowering the collective pitch reduces the overall lift produced by the rotor system, helping to decrease the power required and alleviate the conditions that contribute to vortex ring state. This action prevents further descent and helps the helicopter to regain effective translational lift. Lateral cyclic thrust and anti-torque thrust are not typically part of the traditional recovery procedure for vortex ring state. The primary focus is on increasing airspeed and adjusting collective pitch. It's important to note that the exact recovery procedure may vary depending on the specific helicopter and its flight manual or operating procedures. Pilots should always follow the manufacturer's recommended procedures and receive appropriate training for recovery from vortex ring state. Therefore, in a traditional recovery from a vortex ring state condition, the pilot would increase airspeed and partially lower collective pitch.